Welcome to this TMDL public meeting for Bob White Lake. My name is Jeff Burkus. I am the TMDL program lead, and we're going to be hearing from Andrew Frana, who is the TMDL project lead for Bob White Lake here in a little bit. But I'm going to start things off. I'm going to mention a few things that I think are important to keep in mind throughout this presentation. The first one is that we have a public notice period that is starting right now, and it runs through September 14th. And what that means is that if you have any comments or concerns and would like to voice those, you would need to send those to me at my email address by September 14th of this year. My email address is listed there. It is jeff.burkus@dnr.iowa.gov. You'll also see Andrew's information if you have more technical based questions or just want to chat a little more about the project. He can be reached at andrew.frana@dnr.iowa.gov. So let's get into the presentation a little bit. Again, I'm just going to define a few words up front that I think are important for us to understand. The first term that I wanted to talk about is the word watershed. And to help us do that, we have a map that I wanted to show you here. And Andrew's going to talk more about this map here in a little bit, but watershed's a very important concept for our work. And here we have the Bob White Lake watershed. And we tell that by that dark outline of the landmass there around the Bob White Lake. Everything inside of this dark line is the watershed for Bob White Lake. And a good way to think about this is that if there was a rainstorm that came along and a raindrop falls within the boundaries of that dark outline, that's within the Bob White Lake watershed, and that will eventually run down into Bob White Lake. If the raindrop falls outside of that dark line, it's going to go to a different watershed. It's not going to enter Bob White Lake. So when we're talking about Bob White Lake specifically, we're interested in this land area and this land area only. We use this image on a lot of different maps to try to communicate different types of information. I pulled just one of those maps up to the front just to show you what this might look like. This happens to be a land use map for Bob White Lake. And we can determine what all of these little different colors mean by using this legend down here in the lower right-hand corner. So a lot of this land area in Bob White Lake is this yellow and brown crosshatched here. That is row crop, so that indicates that majority of the time this land here is going to be used for row crop. And you'll see different colors and their corresponding labels here. And so spend some time with these maps to kind of get an idea of what we're trying to communicate here visually. You'll notice a couple other things throughout these maps that I think is important for us to just kind of talk about here. We'll always have a compass rose here to indicate the direction of north and just to get your bearings. We'll also have a scale so that you can see how far things are. And we usually have an inset map. This inset map here, state of Iowa with the 99 counties. You see a little red dot here. That's where Bob White is located in Wayne County. We might zoom in a little bit further. Again, you've got that watershed outline and that darker, more clear area that's involved here is inside of that watershed area. But we're zoomed in here on the lake, and we're showing here down to that legend. What is this? What does this gold and black line mean? What's it mean? Public land. Okay, so anything inside of this is the state park, and then of course that blue area is Bob White Lake. And so you might see us zoom in a little bit, but we're always trying to define what that watershed is with those boundaries. So that's the first concept. The next term that I wanted to talk about is the word impairment. You're going to see this a lot, either within the document that's on our website, or just in this conversation that we're having here today. Impairment is basically a fancy term for saying that we're not meeting the expectations that we have for the water quality in Bob White Lake. We have this set of water quality standards, which are basically like, these are what we expect the water to do. When we don't see those standards getting met, and there's some sort of testing that we do that says that we're not meeting those water quality expectations, then that water body is impaired. And those impairments are important because that's why we're here. That's what we're doing, is we're talking about what's wrong with Bob White Lake and what we need to do to try to fix that. The next terms are point and non-point source pollution. Point source pollution is something that is permitted pollutants from our permitting program. A lot of people like to say that they can point at it, like they can point at a pipe, and if it comes out of that pipe, therefore it's a point source pollution. That's not quite as accurate as saying that it's a permitted source, and so you might hear those interchangeably out in the world. For the most part, though, we're going to be most concerned with non-point source pollution, and non-point basically means all of the pollutant that comes in that's not permitted, and a lot of times it's non-points is just diffuse and coming over in a way that is not easy to point out. And so think about that as rain falling on cropland and running into the stream and pulling along some sediment that might have phosphorus associated with it. That's an example of non-point source pollution because there's not a permit associated with it, and it's not something that is easily identifiable out in the environment. The last term is TMDL, and of course that's a tricky one. We already used it up front. It's in my title. It's in Andrew's title, and so TMDL stands for total maximum daily load. Now, total maximum daily load is a term that kind of defines itself, but then it's kind of confusing. So I like to think about it with using this picture of this pack mule here. And so this pack mule, if you can imagine that there are no boxes on the cart, the pack mule is going to be able to run that cart around the streets, and he's going to be able to do his job just fine. When we put a box on there, it gets a little harder. We put 5 or 10 boxes on there, it gets harder and harder and harder. Eventually, there are so many boxes on the back of this cart that the pack mule flips up in the air. And so this is a comical space where obviously he can't do the job that he's meant to do here. And so they're going to need to take off some of those boxes to be able to get that pack mule back on the ground, and probably a few more until he can run around the streets just fine. Now imagine that that pack mule is Bob White Lake, and the boxes on the cart are the amount of pollutant that we're putting into the lake. Now we can put a few boxes of pollutant into Bob White Lake and it's going to be fine. The water is going to be able to take care of things, and we're still going to be able to meet expectations. But when we put too many boxes of pollutant in the lake, we're going to start to have issues, and to the point where Bob White Lake's up in the air and it can't meet the expectations that we have for it. And so what we're trying to do is we're trying to figure out how many of those boxes that we need to pull off of the back of the cart for Bob White Lake to be able to do what it needs to do. The other piece of this is that we're also going to include an implementation plan. And Andrew's going to talk about some ideas that we have for what that means for the local community to be able to determine what works best for them. But inside of the document that's, again, available online, the implementation plan inside of that is a collection of ideas of what can be done on the land and in the lake to improve the water quality of Bob White Lake. Those two things together, the tipping point, where the number, the actual number, or the TMDL that we're trying to calculate here, and the implementation plan, those two things together are what we call the water quality improvement plan. So you'll see those terms used interchangeably. I do it a lot just because that's the world that we live in. I might refer to the TMDL as the document, but you'll see on the front page of the document that's available, it's called a water quality improvement plan. And then finally, I just wanted to end with pulling one of Andrew's charts forward. And really what I wanted to do here is just say, there's a lot of information on a chart like this, and it can be somewhat intimidating, even for someone like us who we deal with this information all the time. And so what I do when I see a chart like this is the first thing I do is I look at what it's trying to tell me with these labels here on the axes. So down here, this is the year. So the first year of data that we're going to cover here, it looks like it's in 2002, and the last year here is in 2016. And so this time frame here is important to understand what that's trying to communicate here. And then here it says TSI values. Now I'm going to let Andrew talk more about what TSI values are, but I see that these values are going to range from somewhere around the low 50s up into the higher 80s. And then here on this upper part, this legend here, you can see the different colors and shapes and what those correspond to. Now, again, Andrew's going to spend more time on this, but there is a lot of information contained in a chart like this. And obviously you've got this big red line. That's obviously going to be pretty important. Feel free at any map that you're going to see in the document or in this presentation. Take your time with it. If this is presentation, Andrew is going to explain it. If you want, stop, pause, take time to kind of look at it a little more, rewind, and see if you can catch more information the second time, because there is a lot of information that's packed onto these graphs, and it's really important to kind of really take your time to make sure that everything makes sense. And so just a little bit of setup for that. And then I'm going to hand off the rest of the presentation to Andrew, who's going to give you a lot more detail. But thank you for joining us for this presentation.
Thanks for that introduction, Jeff. As he said, my name is Andrew Frana, and I'm the project lead on the Bob White Lake Watershed Improvement Plan. And first of all, I'll be talking about the outline of what this presentation will be about now that we have our terms and definitions all lined out for us. We'll begin by talking about the Water Quality Improvement Plan, what that is, and how we go about making it. Then we'll go into the description of Bob White Lake and its watershed and give you some of the details and characteristics of that. Next, we'll be talking about the Water Quality Assessment, what may be improved with the lake, what our expectations are, and where we can go from there. Then we will talk about the TMDL development, so that how do we get to that tipping point to improve the water quality expectations. And from there, we'll do a brief implementation planning section where we talk about what we can do to improve and get to the expectations of water quality. So first of all, what goes into the Water Quality Improvement Plan? We will first have to monitor and assess a water body. So what that means is we'll actually get out onto a boat, collect water samples, send them off to a lab for analysis, and determine if the lake or stream is impaired or not. And if it's impaired, we'll go to the next step of drafting that Water Quality Improvement Plan to determine potential pollutant sources, where they come from, what allocations there are, do our TMDL calculation, and then, as Jeff noted, we'll add that implementation plan or a list of solutions to help to come to a solution in the watershed. From there, we are here today with a public meeting. We'll be asking for review and comment on our document that we have justifying the TMDL and its calculations. After that will be a lot of future work. Hopefully that will be led by local involvement to implement strategies and practices that will improve the water quality. And then we'll have to continue to monitor the water body to see where we are in terms of water quality expectations. Are they improving? Are they staying the same? Are they declining? And then it's an iterative process to get the water quality where we want it. So here we have a map of the bathymetry for Bob White Lake in Wayne County. Fishermen use this to see where they can park their boat ramps, where the deepest spots are, where the shallows are, to help them find whatever fish they're looking for. But it also has several characteristics about the lake, showing the depth, the average depth, the area of 96 acres. One interesting thing about Bob White Lake was it was actually constructed in 1912 as a way station for steam engines, steam locomotives, to refill the water tanks for those. So it's quite unique in its construction and its original designated use compared to most lakes in Iowa. So if we zoom out from the lake, we'll look at the watershed in a little bit more detail. And again, as Jeff described, the watershed is this black outline that contains all this area where if rainfall were to occur, that rainfall will eventually make its way overland to Bob White Lake. Bob White Lake is located in Wayne County, approximately 2 miles from the city of Allerton. It does flow into the upper South Fork Sheraton River, and the area of the watershed is 3,521 acres. If we compare that to the area of the lake, we have a land to water ratio of 37:1. So what that means is for every 1 acre of lake, there are 37 acres of watershed. So we will see in the document that the land uses, the soil types, and the slopes of the watershed will have a definite impact on the water quality of Bob White Lake. Setting that up, if we talk about the land use for Bob White Lake watershed, we can see that these yellow and brown crosshatches here are row crop, and the brown is what we call extended rotation. So what that means is the row crop is either corn or soybeans depending on the year planted, and this extended rotation is usually a 6-year rotation of corn, soybean, corn, and then several years of meadow, alfalfa, or other grass species. So it still has that row crop nature in there, but it's over an extended period of time. And if we look at the area and percentages, we see that row crop and this extended rotation make up nearly 70% of the watershed, with all others, whether it be grassland, parkland, pasture, these red farmsteads, making up 31%. We take a look at the soil type map. There are 3 main soils, Edina, Clarinda, and Seymour. And some of the characteristics of them are they are poorly drained, and in some of the bottomlands, there may be some tile drainage. So we can see that there's going to be some overland flow issues stemming from that poor drained nature in the upper lands. If we look at the slope distribution, we can see that down here there are several classes from A to F depending on how steep they are, A being the most flat, up to F being the steepest. We can see that 2/3 of the watershed are either class B or C, so that means between 2 to 9% slope. And it's characterized by flat uplands with sloping lowlands, so flatter up here, steeper down here. And if we look with a discerning eye, we can see some of these red stripes here in some of this row crop area. The document talks a little bit more in detail, but these are actually terrace formations where we have a flat area of crop, sloping area to detain water and slow down runoff, and then more areas of alternating crop, slope, crop, terrace, and thus. So the combination of land use assessment, soil type, and slope will help determine the extent and impact that surface runoff, subsurface drainage, and other causes of pollutants to the lake make it to the lake and impact the water quality expectations, as described more in detail in the document. So now we are to the assessment of Bob White Lake. What are the issues? Well, we see that there are 2 types of water clarity issues, first with algae and second with sediment. And we'll talk about that a little bit in more detail as we go on. But when we monitor Bob White Lake, we do several things. We try to do it in the same location. So, if we were to go from here one time and from here the next, we might have a large degree of difference between the two. And we try to do the same test. So we'll test for the same things each time, whether it's nutrient-based, water clarity-based, dissolved oxygen-based, or bacteria. We always want to run those same tests. That way we're comparing apples to apples. And we'll try to do the same times of the year. It doesn't make sense to try to test this in the middle of the winter time when nobody's out there recreating or when the water is frozen over, because that will impact the test. We want to do it during the recreation season, so from March to November, when people might be out recreating on the lake. And here's just a shot of a typical water quality analysis. We'll actually get out on the boat and take samples with various tools before we send them off to the lab. But going back to what defines poor water clarity, we did say already that depending on the time of year and what's going on in the watershed, the lake might either be too green from algae or too murky from turbidity. And we see that Bob White Lake does have issues with both. So it can either be too green like split pea soup or too murky like chocolate milk, depending on the time of the year and what is going on. And what we see here is a tool that we use to measure water clarity in the lake. It's called a Secchi disc. This disc has quadrants of alternating black and white attached to a measuring tape that will measure the distance down of water clarity. And how we measure that is, once we lower that down there, as soon as you cannot tell the difference between the black and the white from the water being too cloudy or too murky, that distance is called the Secchi depth. So anything above that is where you would be able to see the difference. Anything below that, you kind of lose sight of that disc. So the deeper the depth, the clearer the water. All right, now setting up some some of the actual data analysis of this. First of all, we want to look at the axes. What we have here is from 2002 to the end of 2016. So we have a 15-year period of record, which will talk about the different water quality impacts. And then on the y-axis, we have TSI values. Now, Jeff alluded to what these are. They are trophic state indices. And what that means is basically how productive is the lake. Depending on what the value is, higher the value, the main thing is the higher the value, the worse the water quality. The lower the value, the better the water quality. So we want to be below this. And speaking of this red line, this is what we call our impairment limit. The impairment limit for lakes is a TSI value of 65. So if we see extended periods of time above this red line, that means that we are not meeting water quality expectations. If we have it below this red line, that means we are where we want to be, and we are meeting expectations and not being impaired. So if we start to actually look at some values for Bob White Lake, we see some trends develop. First of all, these blue diamonds here are a trophic state index value for Secchi depth. So we just talked about that. Secchi depth would be that depth of water clarity. So a shorter value of water clarity means worse, a shorter Secchi depth. And what we see for these trophic state indices are values above the impairment limit of 65. So we're not having very good values for our Secchi depth. And we see that the entire assessment period as well. So there has been issues historically. Next up, we have these green triangles, which symbolize the TSI for chlorophyll A. Now, don't get hung up on chlorophyll A, the scientific term. What we do is we'll compare that to vegetative growth for algae in the lake. So just think of chlorophyll algae. So these green triangles represent algae growth in the lake for the assessment period. And we can see that sometimes they're above the impairment limit, sometimes they're below, sometimes they're above, depending on what's going on and what's going on. So it's important to remember that although there are some times where it's below, the times that are above still impact the water quality expectations and lead to the impairment. And finally, we have these purple squares that represent the TSI value for TP. TP in this case means total phosphorus, which if you think of fertilizing your lawn or your crops, eventually some of that would make its way to the lake. So we can think of that as nutrients or fertilizers in the lake, depending on where they come from. So these purple squares, again, are above the impairment limit for the entire assessment period from 2002 to the end of 2016. So the takeaways are, we see some pretty significant issues with Secchi depth or water clarity and total phosphorus or nutrient levels in the lake. And one thing that the document describes in detail is that the water clarity at some points may be so poor that it does impact algae growth. So we might actually be light limited in some cases. So if we just go back to quick, what is a TMDL? After we talked about the watershed, the water body, the water quality analysis, and some of the data analysis, we are ready to try to target that tipping point for the total maximum daily load. And speaking of target, that's what the first thing we'll talk about. Then we'll talk about sources of that pollutant. Finally, we'll get to the equation of our tipping point. And then to be useful, we'll try to allocate those pollutant sources a little bit. As the data chart alluded to, our target in this case is phosphorus. It does cause excess algae. If you imagine algae being small plants, they do need nutrients and fertilizer as well. So when there's abundance of phosphorus in the lake, you may see an abundance of algae. And at times that phosphorus is attached to sediment. So if we see an abundance of phosphorus, we will also see an abundance of sediment, which can create cloudy water and impact that water clarity and that Secchi depth, as we talked about. Phosphorus is transported by surface runoff or groundwater flow, depending on the topology of the area. So if you imagine runoff from a field after a heavy rain, you'll see that cloudy water. What you're seeing is silt sediment that also has phosphorus bound to its surface. And so what we want to do is to try to reduce sediment from runoff into the lake, which will hopefully reduce phosphorus as well. So we've talked about our target, Now we'll talk about our sources of where that phosphorus may be coming from. Jeff did talk about two main sources, point sources and non-point sources. Point sources are permitted discharges, something you can point to. Those may be wastewater treatment plants or different communities that are allowed to discharge at any certain time. And we see in Bob White Lake, there are no point sources for phosphorus discharge. Well, what that means is all the potential sources are non-point sources. Several of these types are listed here, but the main one in the document is row crop runoff. Row crop runoff sediments, different types of fertilizer and things like that, that end up making its way to the Bob White Lake. So we've talked about the target being phosphorus. We've talked about the sources being non-point. Now we can talk about that equation or that tipping point for the TMDL where the water quality expectations would not be met. So to break it down into its simplest terms, the TMDL, the total maximum daily load, is the sum of three things. It's the sum of the waste load allocation, the sum of the load allocation, and a margin of safety. The margin of safety is something that we apply to our models and our data to make sure that our estimates are not only professionally sound, but slightly conservative. So if we are estimating at any point, it will be to the improvement or the better value of where we want to be for water quality expectations. So to talk about these components a little bit further, point sources that we talked about would be equivalent to waste load allocation. Non-point sources would be the load allocation, and then we have our margin of safety. We did talk about the waste load allocation or our point sources being 0, so we don't have to worry about that. That leaves all of the remainder to be load allocation and margin of safety. We apply a margin of safety value of 10%, and then the remainder is our load allocation or non-point sources. So to put numbers to that, our TMDL value is 1,971 pounds of total phosphorus per year. 10% for a margin of safety would be 197 pounds, which leaves 1,774 pounds of total phosphorus coming from non-point sources a year to Bob White Lake. If we compare that to historical assessments of the existing water quality, we see that there's quite a difference. The existing TMDL or the existing phosphorus load is almost 20,000 pounds, 19,714. And we see that we need a 90% reduction to meet our TMDL. That may seem like a lot, but we have to remember that these issues are intergenerational and they may take years to see improvements. So we shouldn't get discouraged by that number up front. So back to what we talked about for TMDL, we have our target phosphorus, we have our sources, we have our equation now for the TMDL. And in order to be useful, let's talk about different allocations or where some of that might be coming from. We have our chart here pulled directly from our document. Don't get hung up on these numbers. The main thing right here is we see is row crops being nearly 90% of the phosphorus export to Bob White Lake. And although row crop and extended row crop were only 80%, we see that there is a greater percentage of phosphorus to the lake from any other source. So if we're going to be talking about improving water quality expectations, that may be the best place to start when we talk about our implementation plan. So when we talk about our implementation plan, we do want to include best possible solutions or what we call best management practices. And it will be successful if we have local participation. And we also have to allow for future monitoring in order to see if we are meeting those expectations, if we're improving, if we're staying the same, or if we are declining in water quality. So some different types of best management practices. The first suite would be land management practices or prevention. So if you can think of trying to stop that soil export from even happening or stopping runoff, some types of these are conservation tillage, no tillage, cover crops, and then also managing the amount of manure or nutrient that we put on the soil. If you can imagine, these are meant to prevent loss of soil or loss of phosphorus. An example of this would be no-till farming. We'll have here is a field of soybeans planted over a field of corn. And what we can see is this leftover corn stover from the previous harvest serves several purposes. It can create a bank of organic material, organic matter in the soil that helps soak up water during a rainstorm, but it also absorbs the impact of energy from rain. So if you can imagine a big fat raindrop coming down here and hitting this corn stalk, and then turning into some raindrops that might be either absorbed or slowed down. And you can imagine if that corn stover wasn't there, that raindrop might detach a piece of soil that could eventually run off and make its way to Bob White Lake with phosphorus bound. So there's several benefits to this. If we look at the next type, structural best management practices. So what these do, they stop or intercept pollutants as they are leaving the area during transport. Some examples of those would be terraces, grassed waterways, sediment basins, and wetlands. So once that, in this case, once that runoff, that soil, that phosphorus is moving, how do we stop it from getting further and getting to the lake? One example that we do see in Bob White Lake are various sediment basins laid around. And you can see that what the sediment basin does is it backs up this water, it slows it down, and then we see these heavier silt and sand particles fall out that may also help phosphorus from coming to the lake. So it also helps, it has several benefits. It helps with flood resiliency and trapping nutrients. Finally, we have in-lake remediation of existing issues in the lake. And some of those would be fisheries management, shoreline stabilization, and targeted dredging. And the document talks about these a little bit further, but the lake was drained relatively recently, and the indigenous carp population was removed to help with water quality. Sometimes what you can see with carp or rough fish is that during their feeding, they'll root around and stir up the bottom layer of sediment, and they can resuspend that sediment and resuspend some phosphorus available to algae. So removing those carp can help possibly mitigate those occurrences of water clarity issues. So after all this talk of BMPs, we do have to have some next step. We have to continue to monitor the water quality for improvements. We have to have a locally led effort. Without locally led actors, we will need a potential for greater success with local involvement. Some things they can do, promote awareness, create a watershed group, and then use our document, this water quality improvement plan, to create a watershed management plan or budgets and timelines for different BMPs, and then actually go out into the land and improve those things. And what we can do is possibly provide technical assistance with those plans depending on resource availability. And now I will turn it back over to Jeff for our closing remarks.
Thanks, Andrew. Just wanted to reiterate here at the end that if you have a public comment, that you will need to send that to me, Jeff Burkus, at dnr.iowa.gov by September 14th. And if you have just more basic technical questions or want to talk a little bit more about the project, but don't want to make an official public comment, feel free to reach out to Andrew at any time. You can see his information there. So thank you guys so much for viewing this video, and please let us know if you have any comments or concerns about Bob White Lake. Thanks.